Hello there, students. Today we're going to learn the basics about vectors. So, what is a vector? In a nutshell, anything that has a magnitude or size and a direction is a vector. A quick example would be your velocity while walking to the store. You might be walking down the sidewalk heading east at say 4 kilometers per hour. That has both a magnitude of 4 kilometers per hour and a direction, east. Therefore, it's a vector. In physics, we will come across a lot of quantities that have magnitudes and directions, which we call vectors. They behave in certain ways, and in order to learn physics, we'll need to first learn how to work with vectors. We denote vectors with an arrow over a letter. Here's an example, vector A. If we consider our example again, walking to the store at 4 kilometers per hour east, we might write that down something like this. Vector V for velocity is equal to 4 kilometers per hour east. Let's take a look at a coordinate system now. To be precise, this is a two-dimensional Cartesian coordinate system. The two dimensions here are east going to the right and north heading upward. We denote vectors symbolically as an arrow, starting and ending at some point in space. The base or starting point of the vector is called the tail, while the arrow part is called the head. In this case, we know the magnitude of our velocity vector is 4 kilometers per hour, so it should be 4 units long, and the direction is east, so it should be pointing straight east. We aren't always talking about east or north, though, so we usually label our coordinate systems more generally. For 2 dimensions, we use x instead of east and y instead of north. Now, if we wanted to write out our velocity vector in this more general coordinate system, we might try something like this. Vector v is equal to 4 kilometers per hour in the x direction. But this is a lot to write every time, so mathematicians came up with shorter notations for these things. Instead of saying in the x direction, we use a new type of vector called the unit vector. We denote unit vectors with a funny hat over a letter. Here is unit vector A. Unit vectors have special properties that we will cover in a later video, but most importantly for now, we need to know that they have a magnitude or size of exactly 1 unit. Their main purpose is to point in a specific direction. Along each of our axes, we put one of these unit vectors and give it a label. For the x direction, we use I hat. So we could write out our example as vector v is equal to 4 kilometers per hour I hat. If we ignore the units of our velocity vector, which are kilometers per hour, we now have a vector v is equal to 4 I hat. What this is actually saying is vector v is equal to 4 times of I hat. Well, what does that mean? On our coordinate system, if we place our unit vector I hat along the x-axis and put them head to tail 4 times, we'll recover our initial velocity vector. Awesome. What about the y-axis? What if we wanted to move in the y direction? How would we write that? For this, we assign a new unit vector to travel along the y-axis. This unit vector is j hat. Let's think about our example once more. If we encountered a detour on the way to the store and had to travel north at 3 kilometers per hour while maintaining our initial 4 kilometers per hour east velocity, we could write that like this. Vector v is equal to 4 I hat plus 3 j hat. There are many ways to write vectors, depending on the notation your book or professor uses. In some newer books, they might use more straightforward notations. For instance, instead of I hat and j hat, they might use x hat and y hat. Another common notation is to use angle brackets. We can write the same vector in all 3 notations to see how this looks and compare them. On the coordinate axes, this vector, having a component in both x and y directions, would look like this. For the rest of my videos, I'll be using the angle bracket notation. If you want to learn how I knew to draw this vector like that, stick around and learn more about vectors in the upcoming videos. Thanks for watching and learning about vectors. If you found this useful or want to see a specific topic covered, post a comment below or head over to my Facebook page in the video description.